Aloha, Richard Halverson here. This is ITS128, and I had a little mishap a minute ago, and I started the meeting, and then I clicked the wrong button, and I cut off somebody. But anyway, I'm back here, and so we're starting now. I got kind of a late start this morning. So anyway, let me share my screen. And I hope the person I cut off earlier will rejoin us. But anyway, so we are, let's look at the syllabus. And we're starting chapter 4, I believe, this week. Today is the first week of February, and it's branching. Branching is pretty important. We now know about we now know about many of the different kinds of types of for Python, for how when we're storing a variable, what type of variable. The variables have different types, like whether it's a number or a sentence or something like that. But we're in chapter 4 now, and thanks for rejoining. Sorry I cut you off at the previous just a couple of minutes ago. Okay, so first I want to show you, since this is the second time I've used this textbook. So and I record all my classes. So in this class, I have, if you look in resources, I'm just reminding you. Sometimes people tune in late, and these are all the recordings from my last class. And so we're in chapter 4 here, and you know, these are recordings from a class, so you can know that you know, it's not real quick or anything. They're entire. In fact, these were these were hour and 15-minute classes. So let me just show you a good way to see where a video is, because that's not quite obvious. If you open up a video, and let's just stop it here, and no thanks. And first of all, it's a good idea to click on settings and quality, and make the quality the best quality. That's one thing. And then after that, you can tell where I am in the book by when I have the book on the screen. You should be able to see it across the top. Okay, now this looks like it's taking a while. And so I'm going to come back to this. Second thing I want to mention is that you should go into your go into this cansit.in. The link is at the top of the syllabus, and make sure that's up to date, because every week I make a schedule, and I'm going to post it here at cansit.in. You know, so if ever you forget when I'm having class during the week, then you can check here. Now, I'm probably going to kind of try to be kind of consistent. I'm going to try to get there, but I'm finding that some classes, you know, meeting once a week is fine, you know, in the same class. But then other times it's nice to schedule a second class because there's a lot of material, or people are having trouble understanding, you know, getting it and stuff like that. So, and I think I'm going to try to figure out how to send out emails like an hour before or something, just to remind people. I know that people get mixed up, because like in the middle of the day, you know, I get an email the first time somebody logs into Zoom for a class, and like on some day that I'm not teaching that class, someone will log in, and I'll go, oh geez, you know. So anyway, I will help fix that. I don't think that this is going to come up, but so I'll just tell you along the way here. I wonder why it's not. So if you scroll like here we're in the, I'll just click here. And here we're in the middle of the book, and look at the top here. That's how you can tell where we are. So we are in 4.15. We're looking at the lab exercise. And so right here, I'm probably showing you how to do it, giving you a lot of good hints. And you go along farther, and you see now I'm doing 4.16, and you can go to the end, find the I guess I'm yakking here. Okay. And it looks like I end there. So so that's how you can tell. And so for these videos this time around, I'm probably going to do a little bit less detail. I'm going to highlight the important parts, and I'm hoping that they'll be more compact. But if you're going along and you're having trouble, you can always go back to these older videos, and I'm probably a lot more explicit about explaining how things are. I mean, I probably show you a lot more how to do it. So I just want to mention that. All right, so let's start with chapter 4 in here. And so it's branching. And I'm noticing that I can click on this reporting tab here, and I see how people are progressing. I don't see, we aren't going to see people. And so, some of you are about halfway through. Some of you have started chapter 4 already. So I want to let you folks here know if you're having any problems, keeping up, just let me know. And it's about time I upload the scores to Lima too. So I'll be doing that probably this weekend. You should see that right here. You'll see here. So so this so now we're getting into, okay, so we talked about different types of variables. So now we're getting into more complex program statements. The only statement we've sort of seen so far is the assignment statement, where you have a variable on the left, which is a target. It's going to get a new value on the left, and then there's an equal sign, and then on the right there's some expression that's evaluated to something that is going to fit into the variable. So that's the basic assignment statement. And after that, this first new, more complex statement is the if statement, the if-else statement. And that's where the program can test something to see if something is positive or negative or equal to, or whatever, any kind of test that, and if it's true, it does one bunch of assignment statements. And if it's false, it does a different set of assignment statements. Or maybe if it's true, you do one set of assignment statements, and if it's false, you skip those set of statements. So so that's the concept here. And so this first section here is just trying to get you to understand this concept here. So you should go along and click on all these things, because that's how you get all the points. And here, it's some host, and somebody comes, and party of one comes, and he seats the party of one at the counter. A party of two seated at a small table, and the others are seated at larger tables. And so there's an algorithm that's going on. Okay, and there's branching. Okay, so comes in, party of one, you do one thing. So here's I guess we don't see a flow chart, but so for party of one, you seated at the counter. So that's going on in his head. And so there's a way to express that in Python. And so this just sort of familiarizes or makes sure you understand the concept of if then and branching. It's like here, get a weight. If it's less than 150, then you can say you can ride on some circus ride or something. And if you're can't write, right? I'm not sure what this is. I guess you have to be you have to be at least 150 pounds to ride this thing. Okay, anyway, so so branching, not very interesting. I'm sorry, you have to go through and click through these. You can sort of nest, not nest. Nesting is something different, but you can sort of cascade these if statements. So, let's say you're testing, the year, and if it's 1 year, you do something. If it's another range of years, you do something, but still distinct things. You can set that up like this, where the else can be just another if, and so then it's always, if this is true, then you do some block of something. Otherwise, you skip over it. So that makes sure you understand that. Here we're actually getting into some Python code. Now this is actually how to express it in coding. So here we have if statement executes a group of statements. So here we have where you get a discount if you're over 65. Okay, so it's a program. The hotel rate is 155, and then so you ask the user to enter in the age of the person that wants to rent a hotel room, and if that age is greater than 55, then you just do this section of you execute these statements, and otherwise you go down to the next statement that's at this in the same indentation level. Okay, so in Python, this indentation is important. It's the way that you signify that a section of code is only to be executed if the thing above it at the next outer indent level is true. The indentation is important. It's also important how you indent. In all of the Python tools that we're using, this is like 4 spaces in, right? 1, 2, 3, 3 spaces in. If it's, if that's what you have your tab set to, you cannot mix tabs and 3 spaces, okay? And so it has to be consistent in that way. And by the way, Python is the only language that I know of where actually the indentation of the lines of code matter. Okay, in all the other languages, code is separated by a semicolon, and blocks of code are usually signified or designated by some sort of braces or curly braces or something around it. So that's just something to keep in mind. All right, so when this thing executes, as you can see, if this is true, then it executes the block of code underneath that's indented. Otherwise, it skips over that. It's the same as if it's true, it executes the block of code, and then when it's done, it just continues on. So this line is going to be executed either way. It's just that if you're over 65, this line is also going to be executed just before it. And this sort of gives a visual interpretation of what's going on inside the computer. All right. So here's some exercises to go through. Make sure you do that. Do those. Here's an example of the else, using the else. So here's the other syntax thing we're learning today, where at the leftmost indent level, you have the if, and then the condition. This condition is going to be true or false. If it's true, you execute what's immediately indented. Otherwise, as you're going down, if you find an else, see, there doesn't have to be an else, but if you find an else, then you're going to execute code that you're going to execute a different block of code in the else case. So if the user age is greater than or equal to 25, it's going to execute this code. Otherwise, it's going to, if it's not greater than or equal to 25, in other words, it's less than 25, then it's going to execute this code. All right. And by the way, this is the formatting, which I believe we've learned earlier. And so this is the format. So this is actually what you want to print out. What you actually want to print out is in quotes. But inside those quotes, there are these little curly brace things. And what that means is that what goes in there is defined in the dot format method that's attached onto this string here. And so whatever this value is going to be put right in there. So when this annual price equals $ something prints out, whatever the insurance price is going to go in there. And that's what this is. Annual price, $, and then 4,800, which is what the insurance rate is if you're, 22. Otherwise it's this. All right. So that's the else statement, the else part of the if. And here's some exercises to make sure you understand that. Sets of bonus value is less than 11. What's the final value of bonus value? Well, it looks like it's going to be, since this is true, then we're going to execute this one. And so it's going to be 13, it appears. All right. So here you're showing that you know how to write it, and this is the syntax thing. So, I mean, this is, so you're just writing something like this. Cheat. I'm going to cheat and do this. Copy, paste it here. And I'm going to change this to user age. And I'm going to change this to was greater than 62. Then 62. It's greater than 62. Then this is an assignment statement. I'm going to copy this and I'm going to put that here. Equal. Else, this is the assignment statement. Okay, that looks like that might work. Yes, it is. That's right. Okay. And again, with these participations, I tell people, I notice that when I upload grades, lots of times I see that students have done, all the labs, and maybe they've done all the challenge activities, but there's a lot of participation activities that they haven't done, and that's too bad because I'm sort of, the fact that the participation activities are so easy, and they're fairly substantial points. I mean, it's like, some reasonable percent. And so if you're smarter, I guess, or if you've had this stuff before, then you're almost at a disadvantage because you're gonna be bored going through the participation exercises. Well, you can figure it out because if you do participation exercises at the beginning of the semester or at the end of the semester, you get the same number of points. Okay, so I don't discount for having late. So at the very end, you can see where you are. Okay, and if you've been doing very well in the labs, in other words, if you deserve an A, but you didn't get an A because you didn't do any participation activities, then all you got to do is go back and do a bunch of participation activities. And when you do them, if you want to cheat, be lazy, you can just click. Oh, gotta do it again. Oh, 200. Oh, okay. 200. All right, there we go. Got the participate. See, so you can do that if you want to. But the thing is you'll probably learn something if you got everything right, but you didn't do hardly any participation activities. But if you go back and do the participation activities, it'll be really fast. But you also might learn something, since you'll at least reinforce something. You'll reinforce the syntax in this case. This if else. Do we have any else ifs? Okay, that's something different. here. Okay, this is unique to Python. elif, I wouldn't have even thought of that. In all other languages, it's either else if is one word, or else space if is, just tack it on there. Or in Python, you have this ELI shortened elif. And so there, going back and doing the participation activities, especially if you know many languages, you've learned many languages throughout your programming career, that will help reinforce. I don't know any other language that uses elif. I mean, it's just, the concept is there. This concept is in every programming language, but it's the syntax. All right, so the other thing you got to remember is, double equal sign is where you're testing equality. Okay, if it's a single equal sign, you're assigning. A single equal sign, something is changing. Whatever's on the left of the single equal sign is going to change probably after that statement is executed. Whereas this thing just returns a true or a false. So, all right, so that's multi-branch if statements. So here we're supposed to see if we can print if the year is this or later. In other words, if it's 2021 or later, you print this. Well, you print this. You print this. Otherwise, if it's 2001 or greater, you print this. Otherwise, if it's 1901 or greater, print this. Otherwise, if it's earlier than 19, otherwise you print this. And you're supposed to express that in Python. Okay, so you can do that. You'll have like some elifs. You'll have if, elif, else. Everybody's left me. Well, I assume that people are going to watch this video. You know how? Because I know I get that report. So anyway, but it's usually the students that are really on top of it. They're the ones that will show up for these things, and then they watch a while and they go, geez, this is all just so easy for me, and then they sign off. And so it's probably the ones that don't ever come and see the videos live that should see these videos live. But actually, I know that a lot of people watch them later on because I see the YouTube numbers. All right, so here we're doing some more. We're nesting. See, you can nest them. Why not? See, that's kind of like it's in programming. It's like this is an if then else sort of construct, and this is a statement or a block of statements. This is a statement or a block of statements, and so the if else is a statement. So underneath, if this is true, then you do a statement, and an if else is a statement. So you can have this nesting of statements within statements, and that's an important concept in programming languages today. It's been that way. All right, so here, if this is if the user choice is 1, then it just prints it and we're done. If the user choice is 2, then it asks another question. It depends. So then it looks at the number of items. If it's less than 0, then it prints this. Otherwise, if it's 0 or greater, it prints this. Okay, now if the user choice is neither 1 nor 2, if it's something else, then it's going to print this. So that's pretty straightforward. And here it tests your understanding of being able to follow the code. You're going to write the code, and then you go back and you do what's called desk checking, and you step through the code in your mind to try out the different cases, and test the different cases. And here we have, okay, so this is one way of doing it. This is another way. See, you can do things in more than one way. You can have the elif. There's three ways you can do if something, then else, and then down below that you have another. Inside you have an if, then inside that you have an if, or you can do elifs, or you can just do something like this, usually. But this time, these things you kind of run into problems. And let's see if this is supposed to test that. Okay, there's more than one if statement can execute. Okay, so the user age is less than 16. It prints this. Oh, this is, well, these are pretty much independent. Okay, so if it's greater than 15, so that means, okay, if you're less than 16, okay, so if you're, this starts at 16. 16 or greater, less than 16. Greater than 17, greater than 24. So this is going to execute a number of times. Let's see what this does. User age is 26. Okay, so that's doesn't do anything. This does print. This does print. This does print. This does not print. Okay. Okay, so I was referring to something else when I was talking about the three different ways, but we'll get there. Okay, so here we're supposed to numbot. Well, you know, just follow the code and you can write the answer. Here's a challenge activity. Enter the output for the multiple if-else branches. So here, 4 items. If it's greater than 3, it's a. Okay, so 6 items. It's going to print E M, methinks. Elif. All right, so you can do that. So these are just lists of if statements. That's kind of strange. All right, so if car year is less than or equal to 169, print this. Now, new if statement. If car year is greater than or equal to 1970, then print this. And then if car year is greater than or equal to 1990, then print this. If car year is greater than or equal to 2000, print this. Yeah, okay, that's pretty easy. So that's just a bunch of if statements. And you gotta, you read this, you gotta realize that really we're talking, this should be in front of every one of those numbers. Should be in front of this, and this, and this. And they're just listed. Okay, so so all these, there's a bunch of operators, and you know this already, but just there's a bunch of operators where when they are used in an expression, there's something number operator number that the result of the evaluating the expression is going to end up being true or false rather than some like value. Okay, if it's a plus sign, you're adding 2 numbers, but if it's a double equal sign, then you're testing to see if those 2 numbers are equal. And then there's other ones. There's exclamation point equal, and that's just the opposite of this. But basically, here you're testing if they're not equal. So if they're not equal, the result of the expression being evaluated is going to be true. Whereas here it'd be false if they're not equal. Okay, so there's equality operators, but then there's also, let's keep moving here. Yeah, okay, so here they're just wanting to make sure you understand when to use what. Okay, and then there's these relational operators, and it's still the result of evaluating the expression when you got these in there is going to be true or false. But it's like they're more broad than just the equal and the not equal. There's less than or equal to, and there's just less than, but then there's also less than or equal to. And so in this case, you know how you know this is just the opposite of this. If this ends up being true, then this by definition is going to be false. Well, in this case, in these, this is the opposite of this. Okay, so this is the same as not this, or this is the same as not this, and same with this one and this one. This is the opposite of this. So if this is going to result in something that's true, this one, if you replace it with this thing, it's going to result in the thing being false exactly every time. So anyway, that's interesting. So here we're seeing a number is greater than 10. Greater than or equal to 5 is going to be greater than or equal to. So you got to put that there too. So here they just want you to modify this program where it'll say it's non-negative if the user enters a 0. Okay, so here we're testing if it's 0. It says 0. Otherwise, the opposite case is that it's the same as if. Okay, so they want us to change this where it'll print non-negative or negative, and so you could do something like non-negative. Okay, so non-negative would be greater than or equal to 0, and here you'd be negative. No. Excuse me, less than 0. And here I'm going to put negative. So, 1, 0. See, I'm testing the boundaries. Testing the boundaries of this. 1, 0, -1. There it is. That one flipped. -2, of course. So when you're testing, this is a real simple case. But when you're testing your code, you should test the boundaries, because that's where you can mess up. I mean, someone accidentally does that or something. You can test right there. It's oops, not quite right, and so people can make that kind of mistake. All right, that's another one of these where you're testing. Here you're testing your understanding of less than or equal to versus greater than. This is going to be what happens when it's less than or equal to 5, and this will be what happens when it's not less than or equal to 5, or in other words, when it's greater than 5. $1. If the value of num cents is at least $1. Okay, so you're just supposed to write here, if num cents is greater than or equal to 100. So at least means 100 or more than 100. It's at least 100, but it can be more than 100. So at least is equal. It's equal to 100. It's equal to 100, or it can be more than 100. So is equal to 100, or it can be greater than 100. I wonder if that'll work. That shouldn't work. Let's see if it does work. No, it doesn't. Even the Python, this should be smarter than that. Okay, so no, this equal sign has got to be on this side. All right. Oh, that's right. You can. Okay, this is the only language. I think this is the only language you can do this, where you chain them like that. So, so I'm not used to doing this. You know, usually you'd go if A is less than B and B is less than C. If A is less than B and B is less than C, then do something. So that's how you normally write this. But in Python, you can do this operator chaining thing, which is pretty cool. And so this will you can. All right, I get. No, this is. I'm going to learn something here. Since I'm so used to writing programs in other languages, I wouldn't think to use this chaining thing if I were writing a program today, because you can write. Okay, so I'm going to do this. We'll print in high school if it's great if it's between 9 and 12, so inclusive. So the way I would write this normally would be if user grade is greater than or equal to 9 and user grade is less than or equal to 12, then you want to say that. Otherwise, you say that. So that's one way of doing it. Or, okay, so I'm going to see if it accepts this. Oh, look, it accepted it. What do you know? See here, look, it's testing the boundaries. Okay. But really, what they want you to do is put something like user grade. Is this what they want you to do? Yes. Clever Python. All right, great. That's cool. Okay, so I guess you shouldn't do this. Yeah, due to imprecision of floating point representations. Now, in there's other languages where they actually, instead of converting it to binary and storing it as a binary number, it actually stores it as a base 10 number, and that way you can actually do this, but that's not this language. Anyway, and it's a type. You can declare that as a type. I'm talking about C#. So anyway, okay, so common errors. This is good. It's good to look at common errors. You see that? That's okay. Okay, this will be a problem because it should be a double equal. See, the evaluation of this expression has got to be true or false. And the valuation of this expression is assign num items equal to 10. So I don't know what the result is. Would it be 10? Anyway, so this looks okay. All right. Oh, by the way, I just want to point out that this chapter 4, we're going to be spending 2 weeks on chapter 4. 4 and 5. So I think I'm going to probably spend a bunch of time on, I don't know. Well, I guess we're going to be talking about this next week too. All right, so Boolean. So I'm in section 5, Boolean operators. So you know how we have Booleans, Boolean variables, and Boolean operators. So we have so there's another variable type called Boolean. You know, there's integers and there's floating point and there's strings and there's also Booleans. And so Boolean can only have one of two values, true or false, as you might suspect. And so this is a perfectly legal statement because the result of this expression is going to be true or false. And so we're assigning this variable here, which is no doubt a Boolean variable, which takes on the value true or false. So whatever the result of this, if it's true, then this is going to have a value of true. If this is false, this will have a value of false. And then there's these, there's operations you do on Boolean variables, which you know, it's ands and ors. For anding, both sides got to be true before the result is true. For ors, only one of them has to be true before the result is true. And notting means you just take the variable and make it the opposite. And so there can be complex Boolean expressions, but they're all, you know, like this kind of stuff. Okay, if they're all Boolean variables, then it's all going to be ands and ors, but there can be this kind of stuff in there. And so here we see what they are, and this is how you write them. In other languages, there's actually symbols. And is usually an asterisk, and or is usually a vertical bar, or and can be an ampersand. In Python and PHP, there's it's actually two ampersand. Well, it's one ampersand or two ampersands, and there's a distinction between those. I think in this case, okay. The question always becomes. Let me just tell you this. The question always becomes, let's say you have something like this, and there's an and. Okay, so for this whole expression to be true, they both have to be true. Okay. Now the runtime machine, or the runtime machine, is going to come along, and the first thing it's going to do is it's going to evaluate this. But what happens if that's false? It doesn't need to evaluate this. Okay, so I'm not sure if Python actually goes ahead and evaluates the second thing anyway. It probably doesn't. But in PHP, you can put a different and operator, a single and operator, and it will execute that other one. Why would you want to execute something? Why would you want to execute this if you know that this is true? Well, in some languages, you know, executing something like this still does something. Like in some languages, if you put ++ right after age, you know, you're going to evaluate it just like you would, but then right after it's evaluated, you're going to add 1 to the age. Okay, so if you put a ++ right there, okay, that's not this language. But anyway, all of this is good to know, because if you do become a programmer, no doubt you will be learning other languages, and you'll have to learn other languages. Python is here now, but 10 years from now, the language of the day is not going to be Python, I don't think. Anyway, I'm pretty sure. So there's a lot of good languages out there. So anyways, so the rules of parentheses are the same. You know, you gotta. All right, so like, you know, first you evaluate this, and then you take the not of it. You know. Okay, so this tests your ability to evaluate Boolean expressions. You decide what Boolean operator to put in there. If days is greater than 30 and less than 90, I'm just going to try this. I'm just going to try it. Oh, great. Okay, good. Okay, here you want to evaluate this Boolean expression. If it ends up being true, then you're gonna execute this statement. Otherwise, you're gonna execute this statement. Write an expression using Boolean operators that prints special number if it's this or this or this. well, there's various ways to do it, but in chapter 4, I guess we would do it like this. I'm going to copy this. I want to put it right here just to start. And then I'm going to put if special number, copy, if special number equals or equals, actually, I was just thinking, I shouldn't be using the right mouse button because people on a Mac don't have a right mouse button. But copying and pasting I do, because that way you can see what I'm doing, because you can't see my doing Control C or Control V or Command C or Command V or whatever it is on the Mac. And so that's obvious. And so I'll right click when I'm copying and pasting just so you can see specifically what I'm doing. Knowing on a Mac you would do it differently. Okay, so I'm going to get rid of this comma, and I'm going to paste this, Control V, and put an equal sign there. And that's so I think this is what it is. Pretty sure. Lo and behold. All right, write an expression using the prints eligible if it's greater than but not equal to. Okay, so yeah, you can figure that out. Oh, this one. Write an expression that prints you must be rich if variables young and famous are both true. Young and famous are both true. So how about this? If young and famous. Now this should work because young must be a Boolean variable because the value is true. Famous must be a Boolean variable. So this is a Boolean variable, and this is a Boolean variable, and this is an and. So this is a Boolean expression. So this should be all you need to do. Yeah, so this takes your input and, oh, I see. Okay, so what this program does is it asks the user. It asks the user if the what the value of young is, and if the user types in true, then this expression is going to be true, which means that this variable is going to be assigned the value true. If the person does not type in true, then this expression is going to be false, and then this value will be false. So first it asks what young is, and it asks what famous is, and if the user answers true in both cases, then then it ends up being true. So anyway, so this is probably true, yeah. Or your first name is Richard. Okay, membership and identity operators. Oh, great. Okay, good. What are we doing here? Okay, so these are lists. We're talking about lists now. And there's an in operator. So if something is in a list, which means, how far does this chapter go? Okay, it's 11:25. Oh, okay, yeah, we're almost done. So I wanted to go back, and it was one of these. So now that we have in, where was one of those challenges where where was that one where we're testing if something is equal to something? Is it in this one? I think it was. This one. Okay, so remember I did if special number is equal to this, or it's equal to this, or it's equal to this. So we should be able to do this. If special, don't I change this? Can I change this? Okay. If special num in minus 99, 0, 44. Okay, this should work, I think. It does work. Great. What happens if I do a set? Is this how you do it? I can't remember. Is this how you do a set? Yeah. So anyway, many ways to solve that problem. All right. It is 11:26, and so I covered about the first sections 4.1 through 4.5, and that's it for this week. I showed you earlier, very beginning of this video, I showed you how you can look at the videos from last semester if you would like to get ahead on chapter 4. I'll do another chapter 4 video next week because this is a two-week chapter, and so I'll see you next week. Thanks for watching.